Sometimes you will see angles in trigonometry being measured in degrees, but other times pi. Alright? Now the thing is, not pi, radians. So angles are measured in degrees and also in radians. I was looking at these pi business here. Yeah. But anyway, the thing is, where do these things come from? How you do the conversion? Alright. Let's see how we can understand or remember where this pi business come from and the radian business. Let's make our circle. We have a circle here. Alright. Now remember, you have the radius of the circle from the center to any point on the circumference is the radius. Alright. Now suppose you have two of these and these radii. You have another radius here. You can see that the angle between here would be, remember, is 90 degrees. You see that? Just as a reminder. Now, suppose you have another radius and you open it to this point, this angle, so that this distance coming around here, the distance of this arc from here to here, the arc length equal to 1 of the radius. Alright? This arc length is equal to 1 of the radius. Because I could just write R equal to 1R. 1R is the length of the radius. Alright? Now, the question is, what would be this angle in degrees? How many degrees would that be? Let me see something here. These dots, I'm going to get rid of them. Let's look at it again. Let's look at this thing again. The same circle. Make a copy of it and put it down here. Again, if we should make the radius here, we have this length, this arc length, equal to R. This length is R, alright? And then we do it again. We use straight line. We do this thing again. So we have R again. Remember, this R is from here to here. We make this straight. Now I'm curved properly. This R is from here to here. This R comes along here. Oh, my. I need to line up this thing properly. So this R comes here. And then this R goes here. And here. Good. Then we do it again. We get another R. Alright. So this R goes here to here. We do it again and get yet another R. So we have this arc length. Remember, the arc length is R. Alright. We do it again. Right? And get yet another R. We probably wouldn't be able to do it fully again, but we have some amount of space here, right? Whatever this is. But if we swing this thing right around all the way, we would cover one revolution, and that complete revolution would contain 360 degrees, right? But that one revolution, it would cover one circumference if we add up all the arc lengths going around. Remember, the arc length is part of the circumference. The arc is part of the circumference. So if we go right around with it, right, we would want, let me get rid of this R here. We would be able to find out how many R's we cover. No, this is not a full R. This is part of R, not the full R. Let me redo that. This is part of an R. It wouldn't be a full R. Now, the thing is this. When you calculate the circumference, what's the relationship between the circumference and the radius? The circumference equal, let me put C for circumference, equal, or I'm going to put CIR. I can't bother to keep writing out the CIRCUMFERENCE. So I just shorten it, CIR. The circumference equal what? Do you remember how you calculate the circumference when you know the radius? Circumference is 2 pi r. It's 2 pi r. Alright? Now, let's look at this. This circumference contains 360 degrees. So 360 degrees is equal to 2. Oh boy. Alright, 2. Is equal to 2 pi r. Alright? But remember that this is the radius. From here to here is a radius. Alright? In fact, let me just take a reminder. This is r. From here to here is r. All of these are r's. So from center to circumference is r. But we open the angles so that the arc length is also r. So this length from here to here along the curve here is equal to this length from here to here. Now, 2 pi r. 2 pi r. R in this case is an arc length. So 360 degrees would cover 2 pi arc lengths. Alright? It would cover 2 pi of the arc lengths. Now here, if we divide both sides by 2, we'd say 180 degrees is equal to pi arc lengths radius. Now here, if we should have these angles accurately drawn, then this angle would be equal to 1 radian. Alright? That would be 1 radian. Do you see that? So I can rewrite this and say 180 degrees is equal to pi radians. One hundred and 80 degrees is equal to pi radians. If we double the 180, it's 360, and we would double the pi to 2 pi radians. You see? So what we're saying here, 180 degrees is equal to 2 pi radian. 360 degrees is equal to pi. Oh no, I'm mixing up myself. Let's do that again. .360 degrees is equal to pi radians. One complete rev. Give it 2 pi radians, right? 2 pi. Right. 360 degrees is equal to 2 pi radians. So 1 complete revolution is equal to 2 pi radians. Keep making these mistakes, I guess. It's very, very early in the morning. What time is it now? 4:53, and I woke up long time. Want to go back to bed. So keep making these mistakes. I will soon end this and go back to bed. So, but anyway, we look at this. 360 degrees is equal to 2 pi radians. That means 1 complete revolutions is 2 pi r, which is 2 pi radians, where a radian is the length of the arc, length of part of the circumference that is equal to the radius. They call it radian. Remember? Radius, radian. So half 360, you get 180 is equal to pi radians. If 180 degrees is equal to pi radians. If you half 180, you get 90. Equal half pi, you get pi over 2. Pi over 2 radians, and so on. 3/4. 3 times 90 is 270. 3 times pi over 2 is 3 pi over 2. And so on. Alright? So we can also look at the fact that if we divide both sides by pi, we get 1 radian is equal to 180 over pi degrees. Alright? Now, let's see what the numbers would be. 2 pi So 2, where's pi? Pi is supposed to be here. Oh yeah, 2 pi equal 6.28 something. Alright? Now pi divided by 2 is 1.5 radians. Right? 3 pi over 2, 4.7 something, right? But if you're answering a question with it, just keep it as 2 pi, pi over 2 and so on, unless you're asked to write out the number. Probably to how many decimal places or significant figures, whatever it is, are you going? Or you're asked to write it out, the exact or the approximate figure, whatever it is. Alright, so what we have is degrees and radians. So these are some of the values of degrees and radians. So remember, 1 radian is the angle in the sector of a circle where the arc length that is formed is equal to the radius of the circle, right? So that's 1 radian. And we have the conversion tables here. 360 degrees is 2 pi radian because the circumference is 2 pi r. Alright, so that's it for now. I'll see you in the next video.